Space is often thought of as silent, a vast vacuum, cold and empty, where no sound can travel. And in many ways, that's true. There's no air, no molecules to carry the waves our ears detect. But black holes, those dense, dark enigmas, still make noise. Not noise in the traditional sense, but signals, vibrations, ripples. And in 2015, we heard them for the first time. They came from over 1 billion light-years away, a whisper in the fabric of space-time, a ripple caused by the collision of two black holes spiraling into each other, merging in a dance of gravity so powerful it shook the universe. That signal, a brief chirp detected by LIGO, confirmed a century-old prediction of Einstein's theory, the existence of gravitational waves. Let's pause on that for a moment. Two black holes, invisible, merging. And from that collision, waves traveled across the cosmos, not through matter, but through space itself. These aren't just metaphors. Gravitational waves are real distortions of space-time. When a wave passes through, it stretches and compresses the distances between objects. If you were standing still when one hit you, your height might briefly shrink by less than the width of a proton, and then bounce back. That's how subtle they are, and yet we built instruments sensitive enough to detect them. Twin detectors, miles apart, using lasers, mirrors, and vacuum tubes to measure distortions smaller than an atom. That detection changed everything. It wasn't just proof of Einstein's theory. It was the birth of a new way of observing the universe. Before this, astronomy was mostly visual. We looked at light, visible, infrared, X-rays, gamma rays. But light has limits. It can be blocked, absorbed, distorted. Gravitational waves? They pass through everything. They carry messages from the darkest corners of space, from places light can't escape. With them, we can now hear the universe in a whole new way. And what a sound it is! The merger of black holes is like the crashing of cymbals in a cosmic orchestra, brief, sharp, but powerful enough to ripple through space-time for billions of years. Each detection tells a story of stars long dead, of masses beyond comprehension, of motions that shake the universe. Since 2015, we've detected dozens of black hole mergers, each one slightly different. Some involve equal-mass black holes. Others are mismatched. Some spin. Some don't. But each time, the signal carries information about their mass, their speed, their final moments before becoming one. And sometimes the merger creates something unexpected, a recoil. The newly formed black hole can be kicked through space, like a stone skipping across water, if the collision is uneven. Imagine that, a black hole traveling through space at millions of kilometers per hour, propelled by nothing but its own creation. These are not just curiosities, they're clues. Each wave helps refine our models. Each signal brings us closer to understanding how black holes form, grow, and move. And there's more. Sometimes black hole collisions are accompanied by flashes of light, if there's gas around. When two black holes spiral together in a cloud of matter, the gas can heat up, shine, scream into the void just before being swallowed. This gives us two views of the same event, one in light, one in gravity. A cosmic duet. And soon, we'll be able to hear more than just black holes. Neutron stars, dense remnants of exploded stars, also collide. Their mergers create gravitational waves too, and also produce elements like gold and platinum. You might be wearing atoms forged in one of those ancient collisions, carried from a neutron star merger billions of years ago, across time, into your bloodstream, your jewelry, your memories. Black holes, in their silence, helped us hear that story. And that's the paradox. They emit no light. They swallow sound. But through their gravity, they speak volumes. They are drummers in the cosmic band, silent, invisible, but setting the beat that shakes the stars. And perhaps what's most humbling is this: we didn't even know we could listen. Gravitational wave astronomy is barely a decade old, but it's already rewriting our understanding of the universe. And it's just beginning. In the years to come, more detectors will join the network. They'll be placed in Europe, Japan, even space. Satellites listening to the farthest corners of the cosmos. Together, they'll create a gravitational ear around Earth, allowing us to triangulate, to pinpoint, to watch, or rather to listen, as the universe unfolds. We might one day detect the merging of supermassive black holes, the titans at galactic centers, or hear the rumble of primordial black holes, if they exist, formed moments after the Big Bang. We may even uncover something stranger, because every new way of observing has led to surprises. Radio waves showed us pulsars, X-rays revealed black hole candidates, and now gravitational waves are pulling back another curtain. All thanks to the soundless symphony of black holes. So tonight, as you rest, imagine space not as empty and silent, but alive with rhythm. A universe humming softly in frequencies we've only just begun to hear. A music older than light, played by giants no eye can see, and heard, finally, by minds ready to listen.